introduction to data. Now, there is something called an outcome. So what is an outcome? The result of an activity deemed significant by the business. So you have events. In the events, there are entities. Entities behave differently in different events, but all these events typically have some form of outcome which is important to the business. An outcome is the result of an activity, the result of a business activity, for example. So an outcomes can be value. Outcomes are values, right? So outcome values can either be Boolean, like yes, no. Did the particular, somebody took a test, did they pass or fail? It's a Boolean. Boolean is basically yes or no, an type of data. The outcome can be like a continuous value, like a numeric value. Somebody took a blood pressure test, so the blood pressure value is a continuous value. Like it can range anywhere from 100 to 200. That is your continuous value. Or it can be some form of a classification. A class is basically somebody took a review of a movie, and the rating that you gave might be a class, like excellent, very good, good, fair, bad. That is kind of a classification, a type. That is so outcomes can be of any of these different types. Examples of outcomes: in the case of customer, did the customer do a sale, is a Boolean. Whereas the sale value, how much they bought it for, is a continuous value. Continuous meaning the value that you represent is basically anywhere from 0 to 100 to 2000. It's a continuous value. Patient, the case of patient, the outcome can be the blood pressure reading, which is a continuous outcome, or the type of diabetes the patient is identified as. It is a class, like type A diabetes or type B diabetes. It is a class. In the case of cars, the smog levels is a classification. The level of smog levels like A, B, C, that's a classification. The stopping distances that happens, suppose you do a test for a car, which is an event, and then in that event you're measuring the stopping distances when you do like jam the brakes, and how much distance does it take to stop, come to a full stop. That is a continuous outcome. The smog passed or failed is a Boolean outcome. The type of car, let's say is it a sports car or a family sedan, that is kind of a classification. So these are different outcomes that happen as a result of some event. So outcomes are of pretty important thing in data science, because typically in data science what you're trying to predict is outcomes in the future. You will see more about that later. Now comes what is called as an observation. So what is an observation? An observation is a measurement. It's a measurement of an event. So you measure something about an event deemed significant by the business. So you basically measure an event, measure important things in an event that are important to the business we are talking about. It captures information about the entities involved. So a given event might have multiple entities involved, the characteristics of the entities, the behaviors of the entities, the information about the environment in which the event happens, and the outcomes. So an observation is information about all these things that happens in an event. You basically go and collect all this information and record it in some form. And observation is typically called the system of record. So anywhere you go, you see that people are recording information. Earlier they used to record them in journals, some log books and stuff like that. Now everything is automated, computerized. Either there are scanners who are scanning this information automatically, or somebody is entering into the computer. Whichever form it is called the system of record. An example of observations are in the case of customers, there's a phone call record. It's also called CDRs in telephony parlance. A transaction, like a buying transaction, somebody goes to the store and then goes to buy something, he goes to the point of sale counter and the transaction is recorded there. Or an email offer, an email comes to you offering some product at some value, exciting you to buy something. So all of them are observations. If you look at a patient, doctor visit record, a test result, a data capture from a monitoring device, all of these are observations, different types of observations. And finally, let's look at the car. In the case of a car, a service record is an observation. The car goes for service and the entire findings of the mechanic are logged in the service record. A smoke test result is an observation. So all of these are observations captured in some form and recorded and stored. So finally we get to data. What is a data set? A data set is a collection of observations. So every observation records an event about a set of entities. A collection of observations for a business becomes a data set. Each observation in a data set is typically a record. This we call it more a logical record. When you look at physical record, maybe a given observation might be recorded in multiple forms, multiple user interfaces. There could be like master detailed relationships. All that is fine. But here we are talking about a logical record that represents an observation. Typically, you will have observations having an ID, like a transaction ID, a test ID, a serial number, something like that. So a data set is a collection of these observations. Each record has a set of attributes that point to characteristics, behavior, or outcomes. So if you look at an Excel worksheet, you will see that typically every row would represent like a record or an observation. The Excel worksheet itself is a data set, and every row is an observation, and every column is basically an attribute that points to either one of the characteristics of the entities, the behaviors, or outcomes. A data set can be structured data like database records, spreadsheets. It can be unstructured also. Twitter feeds are an example of unstructured data, newspaper articles. And it can also be like semi-structured, like email. So as a data scientist, you typically deal with different types of data, like structured data, unstructured data, or semi-structured data. And data scientists collect and work on data set. That is the bread and butter for a data scientist, is data, and more data. Data is collected as data sets, collected, stored, worked upon, and predictions are made based on the data set. So data set is the core of data science. What is structured data? The example that you see on the right side is an example of structured data. Data where the attributes are labeled and distinctly visible. You see that every attribute in that particular UI is labeled separately, like vendor ID, vendor name, currency ID, voucher number. Everything is labeled. It is distinctly visible, whether it is being used in a UI, whether it is being stored in a database. This is what you call as structured data being labeled and stored separately. It is easily searchable, it is easily queryable because they are labeled separately. Even when you do storage in a database, they are stored in different columns. So it is easy for you to write an SQL statement to query this data. It can be, of course, stored easily in tables. Tables might be like database tables or Excel worksheets. It's easy to store structured data in general. Unstructured data, on the other hand, is not labeled. So data is going to be like continuous text, like you see on the right side is a text about a Mazda 3 car. So this is the continuous text in which the attributes are not distinctly labeled, but they are present within the data. So things that are highlighted in orange you see are different attributes, like compact is the type of the car, a hatchback is the type of the car, a 6-speed transmission is the transmission the car has. So all of them are present inside the data but not distinctly labeled. So this is what you call as unstructured data. Continuous text, there is no format to it, and your data is hidden or embedded inside the text. And querying, of course, is not going to be easy. When I say querying, we are talking more about not visual inspection, but we're talking about writing computer programs to extract information out of these. Are not going to be easy. Now comes the third form, which is semi-structured data. Now what you see an example here is an email. So what you see in the email is part of the data is structured and part of the data is unstructured. So in the email, you see that some attributes are distinctly labeled, like the from address, to address, CC, subject. They are distinctly labeled and available as separate columns or separate pieces of information, whereas others might be hidden within the entire text that you see there. So you have both structured data and unstructured data mixed up in the case of a semi-structured data. Some examples of semi-structured data could also be like XML documents are semi-structured data. Some information is available in attributes, some information in the C data part of an XML document. So that's all examples of semi-structured data. So in summary, what is that we have seen with respect to data? We have seen an entity, characteristics, environment, event, behavior, outcomes, and observations, and finally data set. So these are the key foundations on which data and data science is built upon. So it is good for you to know and understand each of them. So this completes this part of the section. We will continue on more in another presentation. Thanks.